Do you know kappa value? Are you getting scared of kappa value? Hi, my name is Pradeep Chavan and today we are going to see the example which is given in the AIG manual which we are going to solve manually so that everything will be clear to you, calculation will be clear to you. So let us start. First of all, variation in the measurement system. There is a two kind of measurement system variation. One is accuracy, second is a precision. Accuracy study can be done by bias, linearity, stability, CG, CGK. And precision study can be done by CG, CGK, repeatability and reproducibility. Here we are going to see repeatability and reproducibility for attribute gauge R&R. Prior to that, what is the attribute result? The result in which we are getting pass or fail, result in which we are getting okay and not okay. So there we need to have agreement among the people, agreement among the inspector, agreement in line with master requirement. So we are going to see the example of the AIG manual and we are going to calculate all the required thing including kappa value manually. Guideline for the conducting attribute gauge R&R: minimum of 2 or more operator are required. At least 10 parts should be required. Each part should be measured 2 or more time. Operator should measure part in a random order. Boundary job are taken for the study. Now see, whenever there is a conflict in the okay and not okay, whenever there is a conflict between pass and the fail among the operator, so that has happened for the boundary job when there is a slight difference. So that's why it is needed to have the boundary job for the study. Thing will be more clear if we see the example. So this is a attribute gauge and study example from the AIG manual. So there are 50 job, initial 25 here, later 25 here, total 50 job. Now these are the attribute job. Either you will get okay or not okay. Whenever you get the result okay, it will be written as a 1. Whenever you will get the result not okay, it will be written as a 0. Now these 50 job are measured with variable gauge or the by master, and their status whether it is okay or not okay is reported here in the last column. So here you can see reference reading of the observation or the observation for the initial 25 job are here, for the later 25 job are here. Okay, now I will ask operator 1 to take the reading randomly. So this will be operator A having his first reading. There are three operators: operator A, operator B, operator C. Operator A's first reading will be A1, second reading will be A2, operator A's third reading will be A3. Similarly, B1, B2, B3 for operator B, C1, C2, C3 for the operator C. So they will be taking the reading randomly, and whenever they find okay, then they will be writing as 1, and whenever they will find not okay, they will be writing as a 0. Okay, now let us see calculation part. Now let us try to analyze the data or the observation which are made by operator A and operator B. Now operator A is having 3 reading, operator B is having 3 reading. Now you have to compare the reading of operator A and B. Now this is one example. Now A1 is a column or the first reading of operator A and first reading of operator B, in which how many times both these operators are saying it is okay. That is a 1. 1 is okay. Now if you count, that will be 34. Similarly for the column A2 and B2. So that is second reading of operator A and second reading of operator B. So where they are saying job are okay, that has happened 32 times. In the column A3 and B3 it has happened 31 times. And if I add all these things, then you can say operator A and operator B are saying okay. So that occurrence is 97, or 97 are you can say times they are saying job are okay. Now this is a cross tabulation in which in the column A is there and in the row B is there. So A0 that is not okay, A1 that is okay, B0 not okay, B1 that is okay. Now A is saying okay, B is saying okay. How many? That is a 97. Are you getting me? So same thing we have got from this table, that is 97. So similarly, can we calculate how many times operator A is saying not okay, operator B is saying not okay? So that figure can be calculated by same way, and that can be written here. Even operator A okay, operator B not okay, that can be calculated, that can be written in the respective space or the cell. So I have calculated similarly how I calculated 97. I got operator A saying not okay, operator B is saying not okay, 44. Operator A is saying okay, operator B is saying not okay, that is 3. Then operator B is saying okay and operator A is saying not okay, that are 6. I can add row and column. If I add row, then I will get 47 here. 6 plus 97, that is a 103. Similarly, row can be added, that is a 50. 45 plus 44 plus 6, 3 plus 97, that is a 100. Now this is a total addition either from the column side or the row side, that is a 150. Now what is next? Let us see to the next slide. Here, marginal probability theory will be applied for the AB cross tabulation. Now there are 103 job are there for which operator B is saying it is okay and operator 1 is saying there are 100 job which are okay and total job are 150. So if you apply the probability theory, then you will get 103 divided by 150, that is a 69.69%, 0.69 or the 69% probability is there for which operator B is saying it is okay. There is a 67% probability. How we have got? That is 100 divided by total 150, 0.67 or the 67 probability for the A1 operator, rather A operator. So it is an individual probability. Are you getting me? Now, how many job will be there? Rather, what is the probability for which both the operator will be saying it is okay? Then this individual probability is to be multiplied. That is a 0.69 and 0.67 are to be multiplied, and that will be 0.455. So that is a 45%. So 45% marginal probability will be there for which operator A and B will be saying it is okay. So how we got? Because we got the individual probability is this and individual probability is multiplied and we got this figure. Now because of this probability, what is the expected count? Now this is in terms of percentage. So I require expected count by considering the marginal probability. So whatever marginal probability I got, that should be multiplied by the total, you know, count, that is 150. So 150 into 0.455, that will be 68%, 68.7%. So 68, not 7%, it is a expected count, that is a number. So 68 job will be there for which operator A and operator B will be saying it is okay. This is expected count. Now see whatever data we have got, this is one experiment. Now from that, if such kind of, you know, thing will happen in the future, then what is the probability considering this basic data? So this is a basic thing regarding this. Similarly, I can get the probability, that is a marginal probability and expected count for other cell, that is A0, B0, A is saying not okay, B is saying not okay. Probability is this much, rather marginal probability. For this, that is a 0.23, that is a 0 and 1. And 1 and 0, that is 0.23. This is a marginal probability. Are you getting me? And that can be multiplied by total job. that is 150, and here we will get the expected count. So expected count for the 00 is this, for the 01 is this, 10 is this. Okay. So similarly, cross tabulation for the B and C, A and C can be made. So same thing is followed here. Now marginal probability that number or the figure is not required for the calculation. Of course, it is required for the calculation of the expected count. So here expected count is written, and what are the count? Initial count 0001, that is written. Okay. Now let us see the calculation part of the kappa value. Kappa value is a percentage or the figure which show the agreement between two operator, agreement between operator and the reference value. Now if it is 80%, then you can say there is an agreement between operator A and B 80%. It can be maximum 100%. If it is below, then you can say it is a poor agreement. So thumb rule is that it should be more than 80%. Now how it is calculated? For the calculation, we have taken the agreement between A and B, or the cross tabulation A and B we have taken for the sample calculation. Okay. So kappa value equal to P0 minus P divided by 1 minus P. So what is a P0? P0 is a sum of observed proportions in the diagonal cell. So what is that? Here you can see 44 plus 97. These are the figure divided by 150 equal to 0.94. So P0 is a 0.94. What is a P? That is the sum of expected proportion in the diagonal cell. So here 15.67 and 68.7. So that you have to add here divided by 150. 150 is a total, that is a 0.56. So you have to put in the formula and you have got the result, that is a 0.86. So you can say there is an agreement between operator A and operator B is 86%. Are you getting me? Similarly, you can calculate the agreement between A and C, B and C, C and A, C and B. So these are the figure of the agreement. At the same time, you need to have agreement or the kappa value of all operator, that is ABC, with a reference value. So why it is required? Now see, if there is an agreement between A and B is 80% or more than that, but reference value, agreement with reference value is less. So that means both of them are saying okay, whereas the job is actually not okay, and vice versa. That's why we need to see agreement among themselves as well as the agreement between operator and the reference or the master. There is a one important term, that is effectiveness and miss rate. So let us see how to calculate effectiveness for the appraiser A, operator A. Formula is number of correct decision divided by total number of opportunity for the correct decision. So here denominator will be 50. Why 50? Because there are 50 job are there. Okay. Now number of correct decision, that equal to how, that is 42. But how it is calculated? Now see how many times operator is debiting with a master. Now see, if I see row number 6, row number 14, row number 21, 22, so wherever yellow and pink mark are there, so there is a difference. So operator is saying something different than the actual one. So how many count are there? That are the 8. So 8 count are there where operator has taken the incorrect decision or the wrong decision. So that means out of 50, 42 times he has taken the correct decision. So 42, this how we have got, divided by 50, that is a 0.84 equal to 84%. Next is the miss rate. It is a number of times of which the operator identify a bad sample as a good one. Sample are bad, but he is saying it is a good. It is also called as a type 2 error or the consumer risk, customer risk. Now miss rate for the appraiser, that can be calculated not okay said okay divided by total not okay in the reference value into number of trial. Now here you can see pink color job. So they are said okay, but actually these are not okay. Are you getting me? He is saying one, that is okay, but actually it is not okay. So how many time it has happened? That is a 3. 1, 2 and 3. That is a 3 divided by total not okay in the reference value. So in the reference value, if I count 0 here and here, that will be 16 into number of trial. How many number of trial we have conducted? That is a 3, and that is a 6.3. That is a miss rate for the appraiser A, 6.3%. False alarm, it is the opposite to miss rate. False alarm is the number of times for which operator identify a good sample as a bad one. Now sample are good, but he has identified as a bad. So it is a type 1 error or the producer risk or the producer loss. False alarm for the appraiser can be calculated. Okay said, not okay. Okay, job are okay, but operator saying it is not okay. Let us consider yellow highlighted this thing. Now operator is saying not okay, whereas job is okay. So here in the 14, 21, 41, job are okay, but he's saying not okay. So how many time it has happened? Just count the yellow colored one. That is a 5 divided by total okay in the reference value. In the reference value, you have to count 1. So how many time 1 is there? That is a 34 time. Into number of trial, that is a 3 into 100, that we have got 4.9%. That is a false alarm. Now here false alarm is 4.9, miss rate 6.3. So similarly it can be calculated for the operator B. Similarly you can calculate effectiveness miss rate, this false alarm rate for the operator B, operator C. So these are the value. Same methodology is used for the calculation of this terminology. Now what is important, what is the criteria, acceptance criteria for the effectiveness? It should be more than 90%. If it is between 80 to 90%, then it is a marginally accepted. If it is less than 80%, it is not accepted. Acceptance criteria for the miss rate, it should be less than 2%. Marginally accepted between 2 to 5%. If it is greater than 5%, it is not accepted. Similarly, false alarm rate, it should be less than 5%. If it is between 5 to 10% marginally accepted, it cannot be accepted if it is beyond or the greater than 10%. So that's all from my side. Thank you very much for watching this video. Thank you.